All right, here's perfect problem 6 solutions for math. What is this, 213? So in this problem, you're going to prove the Pythagorean theorem that a squared plus b squared equals c squared, where a and b are the lengths of the legs of a right triangle and c is the length of the hypotenuse of a right triangle. Lots of different ways you can prove the Pythagorean theorem. I think this one, is the easiest of all the different ways. It's this purely geometric proof that you don't really need any special, any deep math knowledge for. You just go through these steps. And so the first step says draw a line perpendicular to AB, so perpendicular to this guy that passes through this point here. So I don't know, maybe the line looks something like this. But the fact that they're perpendicular means that's a 90-degree angle. Label this point D. So this is D right here. And refer to the distance from A to D. So this distance right here, I'm going to call that little d. And the distance from B to D is little e. And the distance from C to D is little f. And this says your picture now contains 3 similar triangles. Prove it. Okay, so to have similar triangles, all angle measures must be the same. So if I call this angle measure here, I don't know, x maybe. I'll call this x. In this right triangle ABC, I have 180 total degrees to use up, and I'm using 90 here. So I have 90 more to use up here and here. If I use up x here, then I got 90 minus x here. So if this is x, this is 90 minus x. And if this is 90 minus x, then I have this right triangle, and these interior angles have 180 to use. Their sum is 180. If I use up 90 of them right here, then I have 90 more to use up between these two. This is 90 minus x of them, then this has to be x of them. I can now either refer to this right triangle to figure out that this angle right here is 90 minus x, or I can say, well, this is 90, so if this is x, this is 90 minus x. This is the complement of this angle. So what you'll now see, maybe I'll label these a little bit better, is that all 3 of my triangles have their angle measures 90 degrees, 90 minus x, and x. So I don't know, I could say, how do you prove this? Triangle ABC, that one goes from x to 90 minus x to the right angle. And so let's look for another one that does that. If you want to go from x to 90 minus x to the right angle, I could say ACD. And I want to go from x to 90 minus x to the right angle, I could say CBD. They all have interior angles of x, 90 minus x, and 90 respectively. So they are similar. So I guess this is step 2 here. Step 3. Nope, that was step 1. Nope, that was step 2. Step 3, using your diagram and your knowledge of similar triangles, fill in the blanks. B over C is equal to what over B? Okay, so B in my diagram is this length. So the length of the side from x to 90 minus x divided by the length of the side from x. Sorry, let me try that again. From B is from x to the 90-degree angle, and C is from x to 90 minus x. So what I want to do is find those same ratios in a different triangle. Maybe it's easier to use these guys. I want to relate together BC and then B something else. So B and C refer to my big triangle, ABC. And if I want to have B and something else, I must be referring to triangle ACD. So I want to take advantage of this similarity here. And that similarity will tell me that the long leg divided by the hypotenuse has to be the same as, when I look in this triangle here, the long leg, which is D, divided by the hypotenuse, which is B. So for part 3, I would say that B over C is equal to D over B, and maybe parenthetically I'll say ratio of long leg to hypotenuse. In ABC and ACD. And then I'm supposed to do something similar down here. So down here I'm relating together A and C and something in A. Well, A and C, again, those come from my big triangle, triangle ABC. And so if I want to relate together the big triangle with something else that has A in it, my only choice is this guy here. So in the big triangle, A is the short leg and C is the hypotenuse. So in this guy here, the short leg over the hypotenuse would be E over A. So I get that A over C is equal to E over A. And this is the ratio of short leg to hypotenuse in ABC and CBD. I'm a little bit low on room, but I think I can make this work. Step 4. Step 4 says solve these equations for a squared and b squared respectively. Note that if you multiply both sides of this equation by b and multiply both sides by c, on this side you'd have b squared, and on this side you would have c times d. And same idea here. If you multiply both sides by a and multiply both sides by c, you get a squared is equal to c times e. And what I'm trying to do is come up with the Pythagorean theorem. Pythagorean theorem says a squared plus b squared equals c squared. So I could take this plus this and say that that's the same as this plus this, CE plus CD. CE plus CD, I could factor a C out from and get C times E plus D. But if you look up in your picture, E plus D is exactly side length C. So I get C times C, aka C squared. So what I have is that a squared plus b squared equals c squared, which is exactly what I was trying to prove.